Hello and welcome. This is an AQA C3 paper for June 2014. Now, I wrote the question on the board that might not be perfectly clear, but hopefully you can, obviously, you can work what it is out from the actual question, because we are going, as I said, from the June 2014 paper. So, this question is quite a nice one to start off with. It's just use of Simpsons Rule. So what I'm going to be doing in this video, obviously is going through each question. This is a bit of a guide. You can skip a few seconds if you want to. As I said, what I'm going to be doing is I'm just going to be going through the questions as I normally would for edexcel. However, because I don't teach AQA syllabus, it's quite close, but this is one of the few topics that's different to edexcel. And I'll explain a little bit about how it's different, just for those of you who do edexcel, just flicking through some papers for AQA as well, so for your benefit obviously, because that's what I did. So this is the Simpsons Rule, right? So the difference between the Simpsons Rule and the Trapezium Rule is that we use in edexcel. Is Trapezium Rule just uses, as you probably guessed, trapeziums. So it overestimates and underestimates certain areas, should we say. Whereas the Simpsons Rule is the same sort of thing, and the formula is almost identical. I say almost because a few things are different. But as I said, I'll point them out when I go through the formula. Yeah, so it's very similar, but the Simpsons Rule just follows the curve, so there's a lot less error. That's all you need to really realise in the Simpsons Rule. I don't know why they don't teach it in edexcel, but as I said, they give you the formula anyway, so it's a nice, easy 4 marks to kick off with there. So hopefully I've explained that. So the first thing I would do is write out the formula. So we'll just call this a function of x. So f of x, call that b and a, and that is equal, obviously with respect to x, sorry, dx. We say that is equal to delta h, or in AQA it's called delta x, but over 3, so it's not over 2. And we say delta h, or delta x, delta h is equal to delta x, which is b take a over n. Okay. Now the key thing with the Simpsons Rule, if you remember, is n is always even. So let's explain that. Anyway, so that's over 3, and then you times that by the first y coordinate, so y0, plus 4 times the second y coordinate, 4 times the first y, so second y coordinate really, plus 2 times the third y coordinate, plus 2 times the second y coordinate, plus 4 times the third y coordinate, and this pattern goes on of 4, 2, 4, 2. But I'm going to summarise this into sort of instead of keep writing individual terms out, I'm just going to put it in a bracket, so you can simplify that, but that's the official rule you get given in the exam. So we're going to stick with that one. So how do we apply it to this idea? Well, obviously we're going to need to find our x and y coordinates. Now, y is obviously equal, so if we write out the equation, so therefore y is equal to the square root of x, or x to the power of a half, times sine x. Okay. Now, tells us we want it in 4 strips, or 5 ordinates, so therefore n is going to be 4, so put n is equal to 4. Now if there's 4 strips, our limits are 0 and pi, then we start from 0 and we go, okay, the first one is 0 plus pi divided by 4, sorry, we've got to work out h is the steps, so therefore to work out h, so if we know n is 4 and we know b and a, so delta h, or delta x, is pi take 0 on 4, so just pi on 4. So each jump is going to be pi on 4. So what I do is a little table, x and y table. So x is obviously going to start at 0. Well, it's actually going to start at 0. This is, if we talk about strips, this is why it's a little bit different. So it's pi on 4, and then pi on 2. And then 3 pi on 2, so 1.5 pi, and then pi. And then you write the corresponding y coordinates, and I get 0.62, and it would go on, and then negative 1.253, and 1.086 and 0. Okay, so they're your corresponding x and y coordinates that you're going to need to sub in at some point. Okay, so you draw yourself a little table, that's what I like to do. And then all we're going to do now is just use that information into our formula. So what I do is I'd rewrite out the equation. So this equation up here, just rewrite it out somewhere else on your page, because now we've got all the key bits of information. You can just continue from where we were at the start. So that's just to say the explanation. You don't need to write this down, but you do need to write. So you do need to write these two bits down. I've done on the table, obviously. Okay, so let's continue. So if we write out the equation again, which is the limits of pi and 0 of x to the power of a half sine x with respect to x equals, so it's pi on 4 over 3, so you could do a third times pi on 4, or I'm just going to write pi on 12. It's up to you, doesn't matter, so you can get the same answer. Should do. And then your first y coordinate, 0.62 really. Sorry, I didn't mean to say that. I've got a terrible blister. I'm just caught it, so ouch. Anyway, right. Not complaining. Oh yeah, sorry, we needed x is 0 here. And obviously gets us a y coordinate 0 as well. So first y coordinate is 0, and our second, yeah, so we add the two zeros together. Oh, sorry, I don't think I've wrote the Simpsons Rule out perfectly, actually. I've missed a little bit off it. Do apologise. And then you add the last y coordinate as well. So you plus yn. So that pattern continues right up to the last y coordinate, where you just write the last y coordinate. So I'm going to write 0 plus 0, and then 4 times all the y coordinates at times by 4. So 4 times, that'll be these two, so 0.62, 1.806. But I'm going to, yep, so 0.62 plus 1.806, 1.086, sorry, plus 2 times the other y coordinate of negative 1.253. Sorry, my scruffy writing. And then that should get you an area of 2.449 square units. I'm to write square units, I haven't because I'm lazy. But that's how you would do that. Okay, so nice and simple question. I haven't really gone into too much detail, partly because I obviously don't teach AQA, so it's quite new to me. But as you can see, I've picked it up quite easily. It's the same sort of method as doing Trapezium Rule, where you write out the equation. You write out the bits that you need to know. So the delta x or delta h in my case mean the same thing. I've just called delta h because I just want to confuse you and I can. And then you write out obviously hopefully you know what n is, and then you work out. You draw a table, the x and y table, and then you put it into your equation here. I mean, you can write out the equation, but I've just done that. Yeah, I wouldn't really recommend it because it's a waste of time, but you know, just to save revise that a little bit longer. Anyway, just to kill you off really. And then write out the equation with the bits of information that you know, so you can't really fail, because you've got the corresponding equation up here to look up to, and the cool information down here. So no real maths when you get to this stage, it's just putting numbers into an equation really, which is maths, but whatever. So anyway, just question 1 of AQA June 2014 C3 paper. Okay, so thanks for watching. Hopefully it's been some help, and we'll see you in another video.